Okay, so now let's take a look at port scanning. So we are going to work with our virtual machines at this point, so we need to disengage from the internet at large, since we do not have permission to perform a pen test on those hosts, so we do want to keep our testing from now on in our lab environment. So our first question is, from a network perspective, what software can we potentially exploit? I don't know necessarily if there's any exploits just because a service is running on the network. It could certainly be free of known vulnerabilities, but on the other hand, it may have known vulnerabilities that we can exploit. On the other hand, there may be software running on a target system that's not listening on a port, it's not available on the network, and it is vulnerable, but without having access to it over the network, we're not going to be able to directly exploit it. We'll look at client-side attacks later in the course, where that will allow us to potentially exploit local software. But for now, we'll stick with what's listening on the network. So we need to know what ports are open and what's listening there. So there are 65,535 TCP ports, and likewise the same amount of UDP ports. You'll be unlikely to find that all ports are open on a single system. You'll probably just see a handful or two, depending on what the function of that host is. You may find, particularly when you're looking at internet-facing systems, they may just have, 2 or 3, even just one, maybe 80 or 443 or both for web servers, 53 for DNS, 25, and then whatever ports they have for like POP3 or IMAP or both. If it's a mail server, you may find more or less, maybe some VPN ports, FTP, SSH, who knows. It really just depends. But internally, you'll probably see a bit more. You'll see some domain ports, certainly, if you have a Windows domain. So it really just depends. The sky is the limit when we're just looking at it and saying, well, what's there before we take a look? It could be anything. Any potential networked vulnerability might be there. So basically what we're doing is starting with a really large picture and making it smaller until we whittle it down to the exact set of vulnerabilities that we're able to find and exploit in the environment. So for these next few sections, I'm going to focus on our Windows XP and our Ubuntu 8.10 hosts. There are other hosts in the course, certainly, but those are the two primary hosts. There's also Windows 7. It does have some vulnerabilities, but other than the website, nothing is a network-based vulnerability, so we'll just focus on those two. So we have Ubuntu and we have Windows XP. So all we need to know at this point are the IP addresses of those two systems. Yours, of course, will probably be different than mine. So mine are 192.168.1.76 and 1.80. So just keep in mind that yours may be different. I also want to make sure that Zerbit software is running. It may fall down at some point, so we need to be able to turn it back on. And again, I'm putting it on a non-standard port, 3232. And we can just say yes to directory listening. All the other software on the Windows XP machine, and as well on the Ubuntu machine, is going to start up automatically. This is just a special service, as we'll see. Alright, so we can certainly just ask what ports are open manually. That's perfectly acceptable. We could do like a netcat. I could tell it I want to ask if port, say, 80 is open. Well, it doesn't tell us anything, but we think, well, it's probably a web server on 80, so what if we ask it? That seems to be an HTTP response. But what if instead we tell it to do netcat verbosely? That way it just automatically tells us that the port's open. We don't have to come up with something that's protocol dependent to get it to talk to us. But if we instead ask for port 81, it says the connection is refused. So port 80 is open on the Windows XP machine and port 81 is closed. So again, we could certainly go through that manually. We could even write a script to do it for us. We made a simple script in our scripting section of the class. We could expand that script a little bit and have it run through all the available ports, or we could, again, use a piece of software that's been specifically designed to do this. Possibly the best known and most powerful port scanner is a tool called Nmap. It, as we'll see, has lots of additional functionality besides just network mapping, but that is its original purpose. So there is a lot of things you can do with Nmap. There is, of course, a man page, but in typical man page fashion, it's not too friendly to read. I would actually say that if we go to nmap.org, there is a book here online that I think is probably a better place to look for reference. Certainly you can use the man page, but I prefer this reference guide over here to the left. Basically an entire book online about Nmap. For instance, target specification, different ways you can specify which targets you'd like to scan. A whole section on that. And of course, kinds of scans. Go back. So port scanning basics, for instance. And so ports are open, closed, filtered, unfiltered. So there's a possibility that there's a firewall between you and the open port. So even if it is open, you may not be able to talk to it. With these particular two hosts, neither one of them are running a host-based firewall. The Windows 7 box is. So if you try and Nmap that one, which you're certainly welcome to do, you will see that far less ports are listening. It's probably because of the Windows firewall. Port scanning techniques. So, like, SS is a Syn Scan for TCP. So TCP, if you are unfamiliar, does a three-way handshake. So we send over a SYN, basically says, hey, I'd like to open a connection. It writes back and it says SYN ACK, so SYN-ACK, and basically acknowledges that we would like to open a connection. And we send back the third part of the handshake, which is an ACK, and that will open up a TCP connection. So with the Syn Scan, what we do is we send over the SYN, listen for the SYN ACK, but then never actually send the ACK. So we don't complete the three-way handshake. Some people call this a stealthy scan. I don't really think it's particularly stealthy. There's nothing to say that someone couldn't log half-open scanning. You could just say anytime someone sends a SYN that we should log it, so it's certainly not completely stealthy. So it's not necessarily really that much better than a full connect scan, which is the next one. So ST would finish up the three-way handshake. And of course there's UDP scans as well. As we'll see, UDP is a little bit harder to scan because it is connectionless. There's other ones as well. There's all sorts of different scans, lots of different ways that have at some point in the past allowed us to bypass filtering technologies. Hopefully any firewalls or other filters that you'll run into today will be able to see through, like ACK scans or Christmas tree scans where you set all the bits on the TCP packet, but at some points it has been able to fool different filters to get by and bypass filters. Hopefully that won't work anymore. There's lots of different scans. Again, I encourage you to, when the video's over, try some different ones. We'll just look at a few basic ones that I use all the time in my pen tests. So let's start with just a Syn Scan. So -s big S. And then we can tell it the hosts we want. Again, there's lots of different ways to specify hosts. Since this is just 2 hosts, it's not too hard to just give a list like this. You can have it pulled from a file with dash, little I, big L. You can do a range, you can do a /24 / whatever net mask you want. And let's do -O for our output. We are going to output these to a file. It is certainly worthwhile to do so. We do want to be keeping good notes in our pen tests, of course. I mean, however you want to do this, for all it matters, you know, pen and paper works. There's tools specifically for keeping pen test notes, like Dratus or Keep Note, but I just like to keep all my output. So this is how Nmap does the output. So it puts it out in 3 different formats. You can specify a specific format, or like I am here, just use a big A for all. That'll put it out in XML format, Nmap format, which is the same as we'll see printed out to the screen, nicely readable and formatted. There's also GNmap, which is greppable Nmap, which, as the name implies, is greppable and easy to use the grep tool to pull specific strings out. So then we just want to tell it the beginning of the name, so I'll just call it class scan. And it'll make class_scan.nmap, class_scan.gnmap, and class_scan.xml. Mine was pretty fast since I'm on my local network. Yours may take a little bit longer. So if we take a look at our output, looks like on 80, which is, let's make this bigger. There we go. On 80, which is the Ubuntu machine, it looks like we've got, for TCP, we've got 21. Note that these services are just a guess at this point. We haven't even finished the connection. We're not really sure what's listening there. Someone could run different software on these ports, but the default for 21 is FTP. Looks like SSH, web server, and like Samba things, network file system. On Windows, looks like FTP, simple mail transfer protocol, so mail server. 80, so we've got a web server here as well. We've got our HTTPS web server. So we've got MySQL, we've got our SMB as well. So anything that's not on those ports is definitely not listening, right? Well, actually wrong. Remember we opened up that Zerbit port 3232, and we don't see that on our list here for XP at all. So as it turns out, Nmap by default only scans the 1000 most interesting, and I'm doing air quotes so you can't see me, interesting in air quotes ports. So I believe they did a Google Summer of Code project and basically had a bunch of students scan the entire internet and did some calculations on it to decide what were the most interesting ports. So you may find that, particularly if you're using a non-standard port, you may find that things are missed. In this case, we know that Zerbit port is there, and it certainly did not respond here. So we can specify specific ports. So let me just clear this so it goes up higher. We can do Nmap, and I can do -SS and 192.168.1.76, and I'll set the port. We can do a range of ports, so we could do all of them like that. Or we'll just set a specific port, so I'll say I want port 3232. And it's open, but the service is unknown. It doesn't know of any standard thing that listens on 3232. So it can miss ports, so I would encourage you to do the full range of ports. You might miss something, particularly internally. You know, there's probably some proprietary something lying around somewhere if they do any development. So we can also do UDP, so -SU for UDP, and this is going to be a little bit different on what we see. So 76 and 80 in my case. Do my output again. I always need to remember to do my output. We'd like to keep our notes. Oops, misspelled 80 there. So this is going to be a little bit slower. Again, UDP is connectionless, so whereas with TCP we should expect to see a response immediately or nothing, with UDP, I mean, how long do you wait? So it is waiting for a second to see if it's going to get a response. And so that could take us a little bit of time to run, even here locally. I mean, we did the TCP on these same systems that are all on this virtual machine network on my host, and it was significantly faster than we're seeing here. I mean, I can always open up another terminal rather than sit here and watch it. And we can also, if you do it, the up arrow, it'll tell you where its timing is at. The time remaining can be completely dead wrong, though, because I guess based on what I've seen, I feel like it basically takes how long it's been running and then how much more it has to do and calculates it that way. But if it does more than one task, it'll take a lot longer to do later tasks, so it can be completely wrong. So, for instance, I think it's been more than 52 seconds since I did that. See, now it thinks it's 1 minute and 13 seconds remaining, so you kind of have to take the time remaining with a grain of salt.
Alright, so we see with the UDP we actually get some different results. We see either open/filtered, opened, or of course the rest of the ports that don't show up are closed. So a little bit different than what we saw with TCP here with the UDP. Open obviously is open, closed is closed, but what is this open/filtered? Why can't it tell? Well, there's no requirement with UDP that there's any callback to you. With TCP, you've got the three-way handshake, so you're always going to get a response if it's open. But with our UDP, since it's connectionless, it's possible you'll get a response from whatever is listening on that port. It may call back to you and say, hey, you sent me the wrong stuff, or, whatever. It's up to whoever wrote it. Or it may just say nothing. It may just act upon your input. It's really up to the developer. So if it receives no response, it's not sure whether it's open or filtered. So if we send it information it doesn't understand and it just ignores us, then we could get open or filtered. Because it would also receive no response if there was a firewall in place that just filtered it out. So it looks like we do have some open and some open/filtered ports on both of them. So it is going to be a little bit harder to deal with the UDP. I've always kind of joked that if you wanted to hide things that were vulnerable in plain sight, you should put them on UDP, because it's a bit more difficult to determine what's there than with TCP. You can do nmap SU and -SV together to do some version scanning for UDP, but it's even slower than UDP, and you might have noticed I kind of cut the video to make it a little bit slower, so if yours took or a little bit faster, rather. So if yours took a little bit longer than mine, no worries, that's normal. So speaking of version scanning, we haven't actually done that yet. That's another nmap scan we can do. And that's going to be nmap-sv and our IP addresses, which of course yours may be different and likely are. And I'll again do my output class version. And this is, again, TCP. We can do an SU-SV and do some version scanning against UDP. Let's see what we can get out here. This, as the name implies, is going to do a little bit more than just telling whether the port is open. It's going to give a best guess of what it thinks is actually listening there. So whereas before when we did the -SS, when we saw the version, I mentioned that it was really just based on what the port was supposed to be doing. Like 21 is supposed to be FTP, 25 is supposed to be SMTP, things like that. And then like MySQL 3306, but when we do the version scanning, it pulls banners and otherwise does some magic to try and make a best guess of what's actually listening there. So it gives us some pretty good version numbers here. Like we have FileZilla, FTP version, SLMail version, Apache. MySQL is unauthorized. You may or may not know what that means. We'll find out. This one even kind of gives us the operating system to some extent, not the version down to the service pack, but it does give us its Microsoft Windows XP, VSFTP 2.3.4, OpenSSH 5.1. This one is Ubuntu Linux, Apache again, Samba, network file system. So a good subset of open ports here. It looks like we've got some potential on both of these hosts. Of course, we forgot all about that extra port that we found, 3232, so we need to either do a -P for the whole range with SV, or we could just do it like this. Just take a single port, makes it a bit quicker. That is on Windows, so 76 in my case. And we see that this kind of hangs a little bit. If we go back to XP and see what's going on, which we have access to it, so we can of course do this. This actually crashes our Zervit program, which we know how to restart. So no problems there. We can just restart it when we're ready, but you may not always be able to do that. If you're on a pen test, chances are, you can hang your head in shame and go to the people who hired you and say that you knocked something over. Can you please put it back up? But the main point that I want to make with this is that you should never tell your customers that nothing will go wrong, because this is just Nmap. All we're doing here is port scanning. It's really unfortunate that people build software that can't hold up to a port scanner, but they do. A lot. Not all the time, of course, but, people who write software aren't always thinking about things like dealing with input that is not expected. So, especially in this case, it's listening on a non-standard port, and Nmap has no idea what it should send it. So, it seems that Zervit, if it doesn't get input that it expects, it just crashes. So, never guarantee to your customers that nothing will go wrong. It is possible something will. Hopefully not at this stage when we're just port scanning, but, you may knock something over, and they need to be aware of that. But again, we can just restart this. And it does, after a little bit of time say, I don't know what this is, but it does print out what it got back before the crash. So you can kind of get an idea by reading this. I mean, it's very ugly, but HTTP 1.0, 20 being a space with the /x, 200 OK, server Zervit 0.4, powered by Carbona. You're going to get an idea of what it is just from that, even though Nmap couldn't decide. Looks like it's Zervit 0.4, which, again, if we were on a fin test, Zervit may be dead forever, and knowing that may or may not do us any good whatsoever. So, it really just depends. Of course, in our case, again, we can just restart it, so no worries there. And that's a little bit about Nmap. Again, I encourage you to go to... So that's a little bit about Nmap. Again, I encourage you to take a look at the website for it. They do have a whole manual with all sorts of different things you can do here. Lots of different scans. So I encourage you to spend some more time with it. It is kind of the backbone of port scanning, the main tool set. But what's also interesting is just based on what we've got with Nmap so far, we can start to get an idea of what we might want to do for our exploitation. Certainly we won't know just from these versions whether or not specific vulnerabilities really exist. We'll need to do some vulnerability analysis, but we can at least start to make a list of vulnerabilities we might want to take a look at later. So, I'm just going to open up another terminal here, and I'll just call it potential vulns. And I'll make it a little bit bigger. And so let's look at our versions. So let's get rid of that. So we've got, say here, VSFTPD 2.3.4. If I put that into Google, VSFTPD 2.3.4. Well, the first thing that comes up is VSFTPD 2.3.4 Backdoor Command Execution. Then right under that, there's a good blog post that actually explains what happened. Basically, the very secure FTP repository was broken into, and the source code was replaced with the original source code with some additional functionality. Specifically, if you put a smiley face in the username, it will spawn a backdoor as root on port 6200. And this was only true for a few days, so they didn't change the version number between it. So just because you have 2.3.4, you don't know if maybe it was downloaded before or after. So it doesn't necessarily mean that this vulnerability is present, but it may be based on the version number. So it sounds like a good thing that we might want to put on our list. I'll just call it the smiley face backdoor, and that is on Linux. If I had a bigger pen test than this, I would probably want to keep track of where things are, what IP address or host name or whatever you want to use. You know, Excel spreadsheets are nice. Just with this one, Windows and Linux is plenty. So let's do one more, and I'll actually give you a little bit of homework to see if you find any other ones. So let's pull this back up and let's do one more here. How about this one? SLMail 5.5. If I put that into Google, again, pretty much the first thing that comes up is that there is a buffer overflow, and it says it's POP3, and this gives me to exploit database, so it'll actually have code for it, which we'll see how to write this kind of code ourselves a bit later in the course when we do exploit development. But it says it's on POP3, so it's going to go to the POP3 port. If you aren't sure what that is, it might actually say in here. Let's see. So it's connecting to port 110. This is port 110. So if we go back to our InMap, yours might actually be different than mine. I set this up in my classes that are live so that it will have already expired. So SLMail will only run for, I think, 15 days on the free version with like POP3 and IMAP. I don't know if it has IMAP, honestly. It has Finger and some other stuff. But after the 15 days, it expires, and it'll only run SMTP on port 25. So if you're like really on point and have already started working on it and have gotten this far in 15 days after you made your VMs, you'll actually see that POP3 port is listening. But if not, then you'll be like me and it's not listening. So it'll be, in that case, an example of a vulnerability that it might be there, but we can't access it because POP3 isn't listening. So again, if yours does have POP3 still listening, feel free to put that on your list, and maybe not, you'll be able to exploit it. Once we get through the rest of exploitation, you'll certainly be able to figure it out. So I'll let you go through these and see if you can find any other potential vulnerabilities. And then in the next section, we will look at actively finding our vulnerabilities with vulnerability scanners, InMap scripting engine, manual analysis, all sorts of things. So I will see you next time.